right, guys, I want to do a few more examples with you about parallel and perpendicular lines on the coordinate grid. So I'm on page 29 in our notebook, okay? And on 29, I want to do these 3 examples with you. So it's kind of a lot of writing. So you might want to like pause the video for a second and copy the questions down and then unpause and then do the problems with me. So if you want to like pause now and write these and then unpause. Okay. So sometimes we already have 2 lines and we want to know if they are parallel, perpendicular, or neither. And so one example of that is where they're not very nice to us at all. Like they give us 2 points for each line, and so I don't know the equation of them or the slopes of them. Oh, but that's interesting. Oh, I didn't even think of that. Now we could go graph these on like graph paper, and you'd probably want to do it on grid paper so that you could easily count your slope with like rise over run. Because really, sorry, I had like an epiphany. I was thinking I have to find the equations of these lines, but I really don't. I really just need to know their slopes because that will tell me if they are parallel, perpendicular, or not. Because parallel lines will always have the same slope. Perpendicular lines will always have opposite and reciprocal slopes. Oh, but I might need to know the y-intercept. Because if they have the same y-intercept, that might be bad. We're going to find the equation just in case. So let's actually start with line AB. Either way, I do need the slope first. So to find the slope, because I don't have graph paper, I'm going to use my slope formula, which is y minus y over x minus x. So I'm going to do 11 minus 3 over -4 minus -8, so plus. So we'll have 8 over 4, which is 2. Now, I could go find the slope of the other one and then have at least a good idea, because maybe if they're perpendicular, it doesn't matter if they have the same y-intercept. So that would save me some work. So if we go down here and find this slope of line CD, again, I'm going to use my slope formula. So we'll do, I'm going to go 3 minus 2 because that will keep it positive, divided by -1 minus 1. So we'll have 1 over -2. Oh my gosh, this worked out so well because my slope here is 2. My slope here is -1 over 2. So because these slopes are opposite reciprocals of each other, that means my lines are perpendicular. So because opposite and reciprocal of each other, I can say that line AB is perpendicular to line CD. That's so nice. I really don't need to know the y-intercept here because if they cross at the y-intercept, that's fine because perpendicular lines will cross each other. And so if it happens there, that's okay. Now, if they had been parallel, I would need to go check the y-intercept because if 2 parallel lines have the same y-intercept, then they end up right on top of each other. And so they're not really parallel. They're the same line, like one on top of the other. And so then we would say neither. So that actually is kind of nice because we saved ourselves some work there. Okay, so because they're opposite reciprocals of each other, the lines are perpendicular. That's how we would answer that question. We do need to show all this work to sort of like prove it to somebody. We want to see like, okay, why? What are the numbers that back this up? Okay, so another example, same question. Are the lines parallel, perpendicular, or neither? Now this time it's a little different. So instead of saying the 2 lines go through these points and maybe I have to find the equation or maybe I just have to find slope, they give me the equation already of the line. Now, if my equation is in y equals mx plus b, then I can see my slope. And remember, parallel, perpendicular, it's all about slope. Okay, so if I have y by itself, I can see my slope very simply or very clearly. But if I don't have y all by itself, then I sure can't. And I need to get it all by itself. So with line 1 right here, y is all by itself, and so I can see that my slope is -1. With line 2 over here, however, y is not by itself, so I'd have to do some work to get it alone. So I'd subtract the x on both sides, and we'd have y equals, now I can't actually combine these, we're just going to write it out, -x plus 20. Now sometimes you might have a number smashed on the y, and so you'd have to divide both sides by that number, but here y is by itself, so I can see now that my slope is -1. And so since they're parallel, I have to do another check. It does seem like they are parallel because the slopes are the same, but I can't have the same y-intercept, and luckily I don't, because one is 6 and one is 20. So my answer here would be line 1 is parallel to line 2 because slopes are the same and y-intercepts are different. It's kind of important that it's both. And again, it's also important that we like show our work here. We prove to the other person, like, yes, this slope is that, and yes, this slope is that. I don't want to just trust them blindly. We need to prove with work and math and numbers. Okay, so last but not least, same question. Are the lines parallel, perpendicular, or neither? So again, they've given me, instead of points that they go through, the equations of the lines. Now these equations are a little bit strange, and I mentioned them in my like little extra linear equation video, that a y equals equation, if we think about this graphically, means that, let's do this one in purple, no matter where I go, y is always 3. So like y is maybe 3 right here. It's also 3 right here, and it's also 3 right here. And so if we like connect our dots, we get a horizontal line. So any y equals with no x is always a horizontal line. And then line 2 right here, because it's just an x and there's no y, that means no matter where I go, x is always -2. So like that could happen here, or here, or here. And so when I connect my dots and get my line, I get a vertical line. And so horizontal and vertical lines are always perpendicular to each other. And it does have to do with a little bit with their slopes. Like the slope of a horizontal line is 0 because I'm rising none, but I'm running as much as I want. So like technically this is 0 over like 1 if you want to call it, or 0 over 2, whatever, doesn't matter. 0 over anything is 0. The slope of a vertical line is undefined because like I'm going up or down as much as I want. So rise, can be whatever, but I'm not running at all. So technically, like fractionally wise, this is like 1 over 0. So they are like reciprocals of each other, because like I could put a negative in front of this weirdness over here and it won't affect anything. So yeah, horizontal and vertical lines are always perpendicular. I think that just kind of makes sense, but it does match with their slopes as well. And so are the lines parallel, perpendicular, or neither? We would say perpendicular. So line 1 is perpendicular to line 2 because they are vertical and horizontal. I should have said that in the other order so they could say respectively, but it's fine. Now, I wish I would have done an example, oh my gosh, my phone's ringing, of neither, but that just means your slopes aren't going to either be opposite reciprocals or the same. Hope that helps. Okay, bye. I got to answer my phone.